Okay, good afternoon, everybody. Welcome to the webinar number 42 of the IEEE Technical Committee on Agricultural Robotics and Automation, November 2016. It's a pleasure to host today Mark Whitty from the University of New South Wales in Australia, who is leading work in the area of practical and precise perception for vineyards. Mark is a person I had the pleasure to visit when I was in Australia last year for the summer school of the Ag Robotics and Automation Committee, and is someone who is doing pioneering work in a very important agricultural area for the country of Australia. And we're going to hear more about this today. Suffice it to say that Australia exports over $1.3 billion US dollars in wines. And it's, of course, an important part of their agricultural output. And the entire work that Mark and his group are doing are strongly related to producing more and better grapes for wine. And in fact, I'll keep the abstract here for everybody to read, but the idea behind the presentation today is actually several-fold. It begins with accurate yield estimation. When growers, Mark, I see that you are there. Give me just a moment. Let me just finish the introduction, and I'll give you the presentation rights.
Oh, good, thanks.
When growers, they have accurate yield estimation, they can do a much better job in terms of managing their supply chain. Once an apple grower told me, imagine if you ran a store or a restaurant and you didn't know how much inventory you had or how much food you had to prepare. That is basically the situation with a lot of fruit growers in the entire world. And grapes is not different. The current practice, or the standard practice, essentially consists of people walking around the fields and, based on experience, doing their best guess as to how much fruit is there. And of course, through robotics and automation, that process can be improved significantly. But Mark's team is not focused only on yield estimation. He's working also on a number of other technologies that are important for vineyards, that include measurement of plant characteristics of phenotypes, including shoot and bunch density, that can then be used for closed loop control by a robot of the canopy of the vineyard. From there, Mark is also working on methodologies or technologies to identify trunk disease or diseases in general automatically, as well as stress, in particularly water stress on the plants. So it's a combination of technologies based on sensing of the vineyard that stretches from yield estimation to plant phenotyping measurements to disease and stress detection that is expected to significantly improve grape production for wines in Australia and perhaps in other places as well. Mark, as we mentioned before, he is with the University of New South Wales in Australia, where he leads the Smart Robotic Viticulture group. And his interests are related to not only the field robotics aspect of the work, but also the more robotics components of it, including 3D mapping, localization, and image processing. The members of the audience today are invited to follow the link at the bottom of the bio here to learn more about Mark's work. So with that, let me ask everybody again to please enter their names on the Join Me list and to mute their phones or microphones at this moment. Mark, are you there?
Yes, can you hear me okay?
Okay, I can. It's a little low, but I can hear you well.
Okay, great. Thanks very much, Marcel.
And your slides are on. And if you would try that mute button, let's see if that works. Okay, this doesn't. Mark, are you there? Yeah, Mark, it seems that that mute button does not really work because it seems that you muted yourself.
Ah, okay. And,
Okay, so if you wouldn't mind, go back one slide and start over. I'd appreciate it.
Sure, great. Okay, hopefully you can all hear now. Is that better, Marcel?
Yes, thank you.
Yes. Okay, great. So just to note, this presentation contains a lot of work that's been done across our group in the last few years, and there's a lot of people to thank, and if I don't mention you all by name, don't feel left out, but there's certainly a lot of contributions that have been made by people, both at UNSW and at our partners. So thank you very much for your contribution, and hopefully you can see more of what we've been doing in contexts. So to start off, to give you an idea of the scale of the problem that we're looking at here, we're talking about wineries in Australia, and there are 2,500 of those. There are tens of thousands of blocks, but when you look worldwide, we're talking about millions and millions of individual vine blocks. And Australia contributes towards the 28 billion litres of wine that is produced each year worldwide. Australia contributes just over 1 billion of those litres, so not an insignificant amount, and the quality of it's quite well renowned, as hopefully most of you can attest to. So where did this all start? Around 2010, we had opportunity to visit a vineyard using a mobile robot from one of our autonomous systems that we'd done previously. You can see it on the left-hand side. That was done for a robot competition, the Magic 2010 work, and lots of people from UNSW contributed to that, particularly Jay Catapidia, Jose Guivant, Steve Cossell, Michael Woods, that helped put together that system and make it running. So we were invited to try it out in the vineyard, and when we were up there, we were able to scan the vines and try and identify what was in them from 3D point clouds and compare them with aerial imagery as well to compare the density of data that we could get. That led to, a few years later, an approach from a team at Treasury Wine Estates in Australia who wanted to look at yield estimation. And that has led to a number of following on projects that I'll talk about today. First of all, yield estimation. Secondly, vine water stress measurements. And then finally, bunch maturity sensing and bunch reconstruction. So first of all, yield estimation. As Marcel mentioned in the introduction, this is currently done using manual methods in general. Farmers will go out there, have a look at the crop, sniff the air and have a look around and say, well, it looks like this year we're going to have 6 tons to the hectare or 10 tons to the hectare. And they'll compare it with historical records, and they'll do some sampling to determine how much fruit's on the vines. But the accuracy they get is not particularly good. It can be up by 50% in some cases. Why does that actually matter? That matters because of the planning and scheduling problem that the farmer has, as well as the planning and scheduling logistics within wineries to which the farmer is providing all of this fruit. So knowing in advance what fruit is coming allows you to allocate space in tanks for different varieties of wines instead of having to combine them in different ways. It also means the farmer can get an idea of the amount of fruit, which is also related to the quality of that fruit. So sometimes they will adjust the amount of fruit on the vines to be able to achieve a certain quality level. So this work, in fact, is actually based on some initial work done in the US by Steve Nuski's group, where they developed a very extensive camera system that's able to drive along the vine rows and image the rows, and from there be able to estimate the yield. So we were looking at methods for improving that, making it lower cost, and doing some more subsampling analysis as well. Just to give you the context in the work that we've done in the last couple of years, we've been out in the field collecting a lot of manual measurements to ground truth all of the data that we have. And as you can see, with 146,000 berries individually counted off bunches, there's quite a lot of information there. So one of the things I want to mention today is that a lot of this data will be available for the community. So if people are interested in doing further work on the image processing or other methods, then please have a chat to me later or get in contact, because we have a lot of time collecting and validating data for this particular project. So let's see what happens if you use manual estimates. And what we're looking at here is a plot of over time. So on the right-hand side of the graph is where we have harvest time, around the 25th of February. And about 5 or 6 months prior to that, the farmer is needing to provide an estimate of what fruit is available. And this is just using manual results. So people will go out in the field, they will put up a frame or a certain sized area, they'll harvest what's there, whether it be inflorescences or small bunches or more developed bunches, and they'll extrapolate from that and the amount of sampling they did to estimate using historical records of bunch weight, berry weight, to determine how much fruit is likely to be on the vine at the end. And each of the blue points on this graph is where we've used even better than the best practice manual methods to try and forecast what the yield will be. And you can see the substantial over time. Coincidentally, it appears that the best estimates come around the shoot stage, very, very early in the season. But that varies significantly depending on the weather conditions following that particular time. So although in this case you can see where the final yield, there are 4 points near the end of the graph on the right-hand side, those 4 points are very close to the final yield, which means that in that block, in that season, we were able to extrapolate from the manual results to obtain what the final harvest value is, which is shown in orange. If you then look at that same block in the next year, you'll see that it tells a different story. The estimates varied significantly over time, and even close to harvest, when using measurements of the berry weight and the bunch weight, the accuracy can be still way off, even right due to close to harvest, which made us think a little bit. Even though we're aiming for an automated solution to estimate this yield, what other factors are there that we need to consider? So one of the experiments that we undertook in the last season was to identify the efficiency of the harvesting done. So in this case, the harvesting is done by a machine. In this case, it's a tow-behind harvester. It's about 10 to 15 years old. And what we did was go along, harvest a section, and try and determine how much fruit was left on the vine, try and determine how much fruit fell on the ground, and this involved a very laborious process of picking up all the berries and bunches that had fallen off after the harvester. But what we found was that of the fruit in the vineyard, around 9% of that actually stayed in the vineyard and didn't end up in harvest bins at the winery. 9% sounds a reasonable amount, and that's what's been used in previous estimates. But you can see if that can be improved, you have an immediate gain in the efficiency, which means you're going to get more income for all those inputs that you've put in throughout the season. Of that, the majority of the fruit that was left in the vineyard, shown on the right pie chart, was fruit that was actually left on the vine. So tuning the harvester in that case would have resulted in a much greater efficiency. In a different block, so this is one where we use variable shoot positioning, and the shoots are trained to be away from the posts in the block to some extent. And this was a self-propelled harvester. We're achieving a harvest efficiency of well over 95%. And of that, the majority of that was berries that fell on the ground. Almost everything was taken off the vine, so a much more efficient harvest arrangement there. For one of our other blocks, we found a harvester efficiency of around 85%. So just highlighting that these numbers do vary significantly. And while the farmers and the wineries are looking for a 5% accuracy in their yield estimate, if you don't know how efficient your harvester is working, that's going to contribute significantly to the fruit you get at the end of the day. So then taking a little bit further, we noticed throughout some of the blocks there was some area where the vines weren't growing particularly well, or where the canopy hadn't extended very well, and there was non-bearing areas or non-productive areas of vine canopy. So what we did here was take a couple of off-the-shelf platforms or quadcopters to fly over the vineyard, then stitch that data together to provide an aerial image using near-infrared plus RGB data. And from that, one of the PhD students working on this project, Julie Tang, was able to provide a method to identify the vine rows and determine which sections of those rows were non-bearing canopy, just using the aerial image. And thankfully, we had a lot of help from people on the ground who went through and manually counted the sections of canopy where there was non-bearing vines or non-productive canopy. And comparing that with the ground truth, you can see on the left-hand side that the accuracy of estimating the amount of non-bearing canopy from the aerial image was pretty good relative to what we'd found on the ground. You'll notice in the second block there, 47A, that there was a significant amount of that canopy non-productive. And so if you're making an assumption about the area of the block and how much fruit you have, or doing a yield estimate on that basis, if you don't consider this non-productive canopy, your estimates can easily be out by that 18% or so. And you notice that the farmers took this information, and then the following season, on the last row, you can see they took some management actions to go there and adjust the vines so that they covered those areas of non-productive canopy and reduced that amount to around 6%. That's a positive outcome from the measurements that we've obtained. So what was our major approach for then doing the yield estimation? We wanted to try out several different units for generating maps of the vineyard. And what we started off with was using simple GoPro cameras. So by mounting them, one on each side of the gator vehicle, as shown in the top left, or on other vehicles, I'll show you in a moment as well, then either stitching together that imagery from video frames facing sideways as moving along the row, or by subsampling the images from that, we're then able to put it through a software system set up particularly by Steve Cossell in the group, who was working as a postdoc with us for this project, to then be able to do image processing operations on all the images that came in and correlate them to a map of the block. So given just the block outline and knowing which way or throughout which rows a driving pattern was undertaken, without having to use GPS, we were able to determine a relative map of various visual vine parameters. So in this case, on the right-hand side, this was a dense shoots where the color of blue indicates how many shoots there were in those areas. And by doing these maps multiple times throughout the season, we're able to plot the development of that particular block over time. This was a quite simple way for farmers to go out and collect the data, just involving putting one camera on each side of an existing vehicle, and basically that's it. Upload the data, and we're able to transform that into an overall map. So some of this work was presented at AgRA Control earlier in the year, and you'll see some other citations throughout the presentation. So this is one of our approaches to doing that with the setup. We used a gator, and you can see a couple of cameras on board there. We first of all tried using backing boards in order to provide a very clear image for the image processing, and the results you'll see later on come from that in particular. But what we've done this year is extended it a little bit further to make it even easier, and if you might just be able to see on each side of the front of the quad bike here, a camera mounted, each one of the GoPros with a battery pack, and by driving that through the block, we're able to image the entire block and count the shoots from that. So we're getting good results so far without using the backing boards, and we think this is something very easy for farmers to roll out, and it will generate very useful maps. And as soon as we have the maps, the farmers are very keen to see them, because they can then take them to go and do management decisions. So for instance, doing variable application of herbicide or pesticide or water or fertilizer or whatever else they need to do, maybe bunch thinning in different areas, or later on in season if you want to do selective harvesting, these maps give you the ability to do that. So how have we gone about doing the image processing? So there's been some work done by another one of my former PhD students, Scarlett Liu, who's been developing algorithms for robustly detecting shoots in these situations. And as you can see, detecting the shoots is not as trivial as you can always imagine, because there's so many different lighting conditions, background conditions, even though there is a backing board. And so she developed some algorithms there that are robust in detecting those shoots, and I'll show you the results on the next couple of slides. So this is the accuracy of shoot detection using just the GoPro imagery on a couple of our years of data. This is by going to a particular section of the vineyard, marking it, counting manually the number of shoots at this stage within a section of about 13 meters long, and then going back and comparing that by taking images from the GoPros across that section, and then transforming that and trying to detect the number of shoots and count them and comparing the direct counts. So usually what we get is an underestimate, which you can see the errors here are in percentages. But in general, for the blocks we get, we're looking at around 10 to 15% error, with some outliers depending on the different lighting conditions or angles or different stages of maturity. There's a particular set of maturity stages labeled for grapevines, ranging from, they're called the EL scale, and it goes from EL 1 or 2 right through to EL 38 at harvest. And we've identified that the best time to do this shoot counting is around EL 9, plus or minus, or ranging from EL 7 to 11 or 12. But EL 9 is the perfect time to do this because the shoots are still distinct but visible, and we're able to count them relatively accurately. How have we actually used all of this? So on the left-hand side of this plot, the two different blocks that we have here, and these were the 2016 vintage. On the left-hand side, you can see the output from these shoot counts, and these are giving you densities of shoots, and then using a conversion factor from shoots to bunches, and estimating the final bunch weight, we can turn that into a map of the predicted or potential yield that's available in that particular block. So you can see there's a particular pattern. So on the top left-hand section of this plot, there's a particular pattern that we're generating from that aerial imagery. And if you compare that with what was achieved on the far right-hand side and the top right, that's the pattern that was achieved at harvest by a harvest-mounted yield monitoring device. So this is where a weigh scale is put on the outflow conveyor of the harvester, connected to GPS, the commercial service that you can get. A number of vineyards in Australia and around the world use it, and they're able to provide a precise measurement of where the yield varies throughout the block. So you can compare these two maps. You can see on the top row in particular, the left-hand side and the right-hand side, you can see a general pattern across the block from left to right. One of the things that we've tried to do here is compare it with what other techniques have been used for yield estimates and mapping. And one of those that's used is aerial imagery or PCD maps. And you can see when you compare even the PCD and the harvester maps, they're not always directly correlated. A lot of people believe they are. Other people believe that the PCD maps will only give you a map of the canopy and not the actual fruit density. So we've seen throughout our project that there's quite some variation between the PCD maps and what you achieve as a final harvest yield map. So the prediction accuracy for these different yield maps varies significantly. If we go back to the accuracy from the shoot counting stage from the yield maps we've done visually, we're getting around 10 to 20% accuracy, depending on the season and the block. And if we compare that with what people are just doing manually, going out there and manually sampling points 5 months prior to harvest, the accuracy of that is around plus or minus 30% using the best practice techniques that we have so far. So we're presenting an improvement in the way that and in particular, the key novelty here is the early stage yield estimate. The ability to estimate the yield, estimate the variations throughout the block as early as 5 months prior to harvest. We've also done some work on detecting bunches here, and this is using an SVM classifier and applying it to, in this case, static images of bunches. And once the classifier is trained, we're getting an accuracy of around 88 to just over 90% in terms of the accuracy of detecting individual bunches on the vines. So that can form part of our overall workflow for the yield estimate. I know there's a lot of interest at present on different methods of doing this bunch detection and in different ways. So to move on then to the water stress project that we've been focusing on for the last year or so. In this particular project, we've been looking at low-cost and simple and precise techniques for monitoring how stressed vines are in a vineyard. And this is of particular interest in the Murray area of Australia, where a lot of vines require irrigation. To do that, you need to know how much water to apply. For the farmer to go out there and understand how stressed each vine is in terms of the available water for it, it takes a lot of time and effort, and it is somewhat subjective, because the farmer wants to believe that the crop is performing well, and he doesn't need to apply too much more water. But if we can find a way to reliably estimate that across varieties, across different blocks, we can provide better feedback to the farmer. So this is a Wine Australia funded project going on in collaboration with STARDI and the Australian Wine Research Institute. So here we were aiming to find a simple sensor that can be used with a mobile phone for easy estimation of the vine water stress. So we've tried 4 different devices. The first one was a pocket spectrometer that's pointed directly at the leaves and to try and determine if we can correlate the spectrometer readings to the water stress level. The second one is to use a stereo camera setup to go and photograph each leaf, because according to the literature, the degree of curl of each leaf, or how shaped it is, or how cupped it is supposed to be correlated to water stress. Thirdly, we looked at a number of techniques in the field to use microscopes, both in the field and on labs taken off, leaves taken off and analyzed in the lab. And finally, we looked at using a FLIR one or a number of different thermal to estimate this water stress. We knew before we started that the thermal cameras were going to be quite good at this, because there have been some results using larger scale cameras that correlated with what's called the crop water stress index, which uses references on a dry and a wet leaf and looks at the relative temperature of the canopy to those 2 reference temperatures. So what's happened, and how did we actually ground truth all of these results? we went out there and used a pressure chamber to measure the stem water potential, which is a way of taking a leaf off and determining by applying pressure to it how much water comes out and how long it takes for that to come out, which gives you an idea of how stressed that particular leaf is. We also used a porometer, so a handheld device that's clipped onto a leaf to measure the humidity underneath the leaves, which also gives an indicator of how much water is inside the stomates on the bottom of the leaf and how easy is it for that water to come out. So these are common measurements used in the field to measure the water stress, but to set up the equipment and use it is not quite as easy as we'd like. So if we can find a simple and a wider equipment that can provide a measurement across a wider area of the canopy, not just a single leaf, that would be very efficient for farmers. So when we looked at the spectrometer, from these results you can basically see they're all over the place. Using a couple of different varieties and a couple of hundred measurements of leaves, we could not generate a distinctive pattern using the provided software for identifying suitable wavelengths in the spectrometer readings. There was no clear correlation with the water stress. So that one got crossed out on a list of options to try. We also tried measuring the leaf curl with the stereo camera. And from this we weren't able to pick up sufficient variation in the leaf curl using the stereo camera, and there was significant variation within a vine and even between different varieties. So this so far hasn't proved to be very helpful in identifying that water stress degree. We've had more success using stomatal measurements. So on the underside of the leaf, the size and the eccentricity of each of these stomates is an indicator of how well it's breathing effectively, and that tells you whether the crop is stressed or not. And we have been able to detect differences in the leaf or patterns from leaves. In this case, taken from nail polish or applied to the bottom of the leaf, allowed to dry and then peeled off and then looked at under a microscope. And we've been able to detect a correlation there between the eccentricity of these stomates and the water stress. But the difficulty is getting this imagery out in the field. So we've tried a number of field-based microscopes, and none of them have had the degree of magnification and the clarity able to be used in the field that we can get with a lab-based microscope. So although there's potential to take that a little bit further, and we've got some results published in a paper as mentioned on the bottom there, it's not the most promising approach at the moment. What has been most promising is the thermal camera results. So this is where you can see thermal camera imagery. That's the bottom left of these images. This is a photograph of a section of vine canopy with a particular wet leaf and a dry leaf there as reference temperature. And from that, we've made an app that can take a photo of the canopy with some assistance to detect where the wet and the dry leaf reference temperatures locations are. We can then automatically detect the rest of the canopy and calculate a crop water stress index for that, which we can then correlate to the overall water stress of the vines. Results have been very good so far with that, and we've turned that into a system that we're going out to beta testers in the next few weeks, where we can actually record the locations, times, and images from each of those and sync them back to our servers. So these results have been very promising, and we're looking forward to trying them more throughout this particular season. One of the challenges, however, is identifying suitable wet and dry surfaces as reference surfaces. So these need to be something that match the temperature of the coolest and the hottest leaves within the canopy, and from those and from measurements of leaves that are actually transpiring and leaves that are not, or leaves that are completely wet, we can try and identify that water stress index. But finding a material and a way to identify those in the image is one of our current challenges, and we're testing out quite a number of materials right now. To move on then to the next project, another of my PhD students, Julie, again is working on maturity estimation. So some work has been done on this for individual bunches, and what we're aiming to do here is take imagery of the entire vineyard, similar to what you saw for the shoot stage, and then identify which wavelengths of that are appropriate for determining the bunch maturity parameters. So there are 4 different parameters that are used there by vineyards and commonly to determine how mature the bunches are around harvest, and identify the suitable and corresponding wavelengths to that in order to develop a sensor that we can directly apply for large-scale, non-destructive estimation of vine maturity. Results are good, looking good so far in comparison with the chemical analysis, but stay tuned for more information in this area in the next couple of years. Finally, I'd like to talk about the bunch reconstruction work. So this has been, starting out from collecting quite a number of images of bunches over time. In each of these animations, you can see where, as part of the yield estimation project, we've been tracking different bunches. So it's 4 different bunches, 2 varieties, 2 locations. And we have images for about 320 individual bunches, imaged every week or 2 weeks throughout the season. And we're using these to try and determine berry diameter, changes in berry diameter, changes in bunch volume, changes in bunch sparseness, which are an indicator of disease risk, and other parameters that you can use for doing phenotyping. So as I said, there's quite a lot of data that we've collected there, and if people are interested in working with us on that, then please get in contact. We'd love to hear from you. So another former PhD student, Scarlett, was working on a method for reconstructing these bunches from a single image, and the particular novelty here is it's a single image. It's not a stereo image. It's something that can be taken in the field, or it can be taken in the lab. Single photograph of a bunch to estimate various bunch parameters. The first one being the number of berries on the bunch, which we can use as one of the inputs for final yield estimation. So this work has actually been turned into an app, which we're hoping to release soon, and I'll show you a little bit more in a few seconds. The accuracy of this is quite outstanding. From just a single image, we're able to estimate the accuracy of purple bunches, or the number of berries on purple bunches, just to about 13% error, and for green bunches with a little less distinct differences between the berry colors, to about 15% error, or even less. And this varies throughout time. So you can see on the right-hand side, around veraison, the higher error on the 1st of November, you can see there, is because the bunch has just formed at that stage. But from any time, once the bunch has actually formed, throughout or through to harvest, we're getting accuracies of less than 15% and down to 10% in many cases from a single bunch photo. This is not being trained on a particular model, it's not variety specific, and it operates very quickly and efficiently. So this little animation will give you an idea of how we see this being used for farmers, one of the outputs that we can generate from the project. So the idea is that take a photo of an individual bunch on a phone. The phone itself has the capability, and we have the app running to do the processing to detect things like berry number, the sparse factor, berry diameters, and estimate disease risk. And because the phones have the ability to record their location as well, we can easily map these. And once you can provide a map of these and show variation across the block, as you can see now, we can do kriging to provide an estimate of overall or any of those bunch parameters, and the farmer can use that for the yield estimate in order to determine things like the order of harvesting, which helps in arranging the logistics to know when and where he needs to apply the labor, when and where he needs to provide equipment in order to get to harvest and save as much money as possible in the process. So that's the conclusion for my presentation today. What we've done in yield estimation has been ways to efficiently use simple hardware to estimate what the overall yield in blocks are. In particular, to be able to generate yield maps very, very early in the season. We believe the earliest possible yield maps that you can get. It removes the tedious and biased sampling that's possible by manual methods. And the accuracy we're getting are better than manual methods as early as the shoot stage. We've also found ways to do sensing of bunch maturity and the number of berries per bunch across the block, and also looked at a solution for determining vine water stress using mobile phones. That's how we've been able to put together a solution for precise locating and precise measurement of parameters through each bunch. So overall, I have to think about where we're going next. We're rolling out these apps, so stay tuned for being able to use them in your field testing or vineyards. We'd love to make the data sets available for people to use in the community. They have been validated very carefully. We've tested this on 2 different varieties and 2 different trellis types, to vertical shoot positioned or very well-trained canopy and a sprawling canopy style, which is quite common in Australia. And we've been able to show good results from both of those situations. We'd love to go out there and automate the process of data collection, whether that's using aerial vehicles or ground vehicles. But one of the things we need to say is that getting data access in the vineyards is really critical. So although a lot of the processing we can do is on the mobile phones or on devices on the farms, which is great, if you want to do a lot of the heavy lifting and large data analysis, you need to be able to get that back to somewhere or a central server. In Australia, the rollout of the National Broadband Network has been something that's really helped us on both of our field sites in the last year in particular. There's a lot of people that have contributed to this. I should mention in particular Angus Davidson from Treasury, who started it all off, and Catherine, who's also working there with us on these particular projects. Greg Dunn has helped from New South Wales Department of Primary Industries in leading the yield estimation project. Paul Petrie and Mark Skews have been involved in these projects as well at SARDI and the Australian Wine Research Institute. And there's a large team at UNSW that have helped support this. And if I haven't mentioned everybody by name, apologies for that, but I know that there have been lots of contributions. So thank you very much to everyone, and thanks for your attention today. Over to you, Marcel.
Mark, thanks a lot. This is great. Yes, Steve Nuske has done some great work in yield estimation itself here at Carnegie Mellon. I confess I haven't followed much of his latest work after I left Carnegie Mellon a couple of years ago. But it's great to see that you guys are going above and beyond, the more traditional yield estimation, which in and of itself, as you point out, is a difficult problem. But then there is a bunch of other, well, no pun intended here, but there's a bunch of other interesting problems that are related and you can address with the same technology, right? The same sensors that you already have in the field. You can then collect more data and do a lot of other interesting analysis.
Yeah, that's right, Marcel. So, for example, one of the things we'll be starting to look at next year is the disease or Eutypa detection in the vines based on the imagery that we've already collected. So applying the same style imaging processing techniques, we'll be able to estimate the amount of disease throughout the block, which is a major factor for health of the Australian wine industry at the moment.
So the question I actually had, I'm inviting everybody, of course, to ask questions. People should unmute their phones now and submit questions here on the chat window. We already have one from Andrew. If I may just get started, and then we let people write their questions on the chat window. But it's related to your last point here, Mark. Industry needs to improve data access in vineyards. As I'm watching the presentation, I'm looking at all these vineyards where you guys are operating, and some look like research vineyards, some look like commercial vineyards. I was wondering about the receptivity. I'm not sure if that's a valid word. The reception of the commercial vineyards to the work. How receptive are they? Are they opening their spaces, their vineyards for you guys to come in and work? There is always, of course, growers that are more technology-oriented, first adopters, early adopters, and those that wait for the technology to mature. How is that relationship on your side, working with commercial vineyards?
It's been absolutely fantastic for us. We've worked in 2 particular commercial vineyards here. So the larger company in Australia, so Treasury Wine Estates, produces the largest value of fruit in Australia, so one of the largest winemaking companies, and they've given access to vineyards that we can use in the Clare Valley in South Australia, and have supported us extensively along the way. And hopefully there's opportunities to roll it out across more of the vineyards, and certainly there's been a lot of interest from me there. The original work that we did was with Justin Jarrett in Jarrett's Wines at Orange, now running under the Seesaw wine brand. He's a small to medium enterprise that has around 190 hectares of vines on one of his properties, and he's been, again, outstanding in providing us access to the vineyards, probably a few tons of grapes here and there that we've been using in terms of the measurement, but yeah, definitely access to the vines there, and input and support from everyone has been no problem at all. We've presented some of this work at the Australian Wine Industry Tech Conference in July this year, and had plenty of interest from growers around Australia who want to roll it out and see it happening. So I don't see that many barriers to adoption. The value for the farmers is significant. It's estimated that across Australia, up to $100 or more million each year is money lost due to inaccurate yield estimation. So it is a significant problem, and we're definitely keen to get more people involved, or more vineyards involved.
That's
so
wonderful.
The only other vineyard that we've used has been a test, one research vineyard just for the water stress project down at Loxton in South Australia, and of course that's a great place to work as well. But most of the data we've collected has been from commercial vineyards.
Very nice. Andrew from New Zealand, he had a question on the chat window. Can you get it there?
I can't seem to see the question. Would you be able to read it for me, Marcel? I can't see the question on the chat window.
You know, something funny happened on my side. As you were talking, Join, it crashed. And then I reloaded it, and my chat window was completely wiped out. Andrew, would you mind retyping the question, or just